Some of you have already placed definitions and videos on our blog and about what polynomials are, and they come in different shapes and sizes, but you can classify them by how long they are. If they have one term, like these two, they're called monomials. If they have two terms, like these ones, they're called binomials. Three terms would be trinomials, but in general, polynomials have many terms, and they can have loads and loads and loads, or they can have not very many, but it's a general name for an algebraic expression where the different terms are added together. We also describe polynomials by their order. The order is the highest power, the combination of the highest powers in one term. So if I look at this one here, this polynomial, the highest term here is this one. The one with the highest power is 4x cubed, which makes this one have an order of 3. This one has a combination of different variables in each term. So we've got an x squared here and a y, and that's got order 3. This one's got xy cubed, that one, and a z as well. That term there has got order 5. So the polynomial in total, the one with the highest number of variables, is this one here. So this would be order 5. It's whichever one has the most variables takes precedence. So that's order 5. This one, the highest power, is this term here with order 11. It doesn't matter if this one's got a -4, this one's got a 1, or this one's got a 0. This one would have order 1. This one's got order 0. You could think of that 3 as being 3x to the power 0. So that's order 0. This one has order 2. This one has order 1, because that's 7x to the power 1. This one, we've got 3 for that term, also 3 for that term. So this one would be order 3. And it's quite useful to have a look at the order, because when we start combining these together, the order helps us to decide what can be added and what cannot be added together. Let's have a look at some addition and subtraction of these, the first step in our polynomial mission. And I've got two different great big polynomials here. This one has order 4. This is the highest number of variables in a single term. This one, the highest power is a 3. That one's a 3 as well, that one's a 3. So when we add these two together, only terms with exactly the same number of variables, in fact exactly the same variables, can be added together. So I can't add that term to anything in g of x because there's nothing like it. There's nothing with order 4, and there's certainly nothing with an x squared and a y squared. In f of x, there's nothing with an x cubed, so these two terms cannot be combined with anything else. So they'll appear separately in the answer. But I do have an x squared y here and an x squared y here, so these terms can be added together. And the best way to actually combine polynomials together when you're adding and subtracting is to line them up nice and neatly. So my f of x can be written out again with the highest power at the front. I'm going to leave a gap for that power of 3, and I've got minus x squared y minus 8xy squared plus 5x minus 10. For g of x, which I'm adding together with f of x, I'm going to put the 5x cubed. I mean, you can do this in different ways, but I'm trying to be organized in lining these up. Minus x squared y can go here. That one lines up with that one. That's exactly matching. It has to be exactly the same letters with the same powers. So that's plus 7xy squared. The minus 2x can go here, and the plus 15 can go here. And then I go through and I add together all the like terms. Just like if you were adding two numbers together and you're adding different columns. This is classified as a different column from this one. They are not the same sort of powers. So that plus nothing is just the same. There's nothing to add together to that, so that's just 5x cubed. This one and this one together would make it minus one of these plus minus 9 of these, which would give me 10. Then those two together, minus 8 plus 7 is going to give me minus 1. Those two together just give me plus 3x, and then minus 10 plus 15 gives me a plus 5. So the answer on the other end is massive. You just have to be organized in your approach to doing this. You don't necessarily have to write it out in the same way I have, but you have to make sure that the like terms go together. It's especially true if you're subtracting, because here I'm going to take this polynomial and subtract this one away. And again, you can only combine together ones with the same terms, but you have to be careful about your negative signs. So I'm going to write out j of x at the top. And then line up the ones from k of x. So the 3 can go here. I've got minus x squared plus 6x plus 12. And I am strictly going to subtract away all of this away from the first one. So k of x is being subtracted away from here. So 10x to the power of 4 take away nothing, it's just 10x to the power of 4. 7x cubed take away 3x cubed, that gives me 4x cubed. Here I've got 4x squared minus x squared is the same as adding an extra x squared. So I've got plus 5x squared. Minus 100 take away plus 6 gives me a minus 106x. And then 4 subtract 12 gives me minus 8. It's just worth slowing down a little bit when you're doing subtractions, because there can be, you could be subtracting a positive number, you could be subtracting a negative number, you could be starting with a positive value, you could be starting with a negative value. So there are 4 different things that could possibly happen. And depending on the size of the numbers, it's easy to get mixed up. So there's no rush with this sort of thing. Especially if you end up with something which has got x's and y's and a's and b's and all sorts of things going on. So here we've got a polynomial order 5. This one is order 6. I'm going to be doing this one, take away this one. I'm going to line up the ones with the highest orders furthest to the left. So my p of x, I'll put that first. 4x cubed y squared, and so on. And I'm subtracting away, that one is going to be by itself here. This one doesn't match up with this one, but it does match up with that one. So I can put that one underneath there. Xy squared can match up with that one. And that's everything. There's just 3 terms there. But I am subtracting. Let me just double check this. This is p of x here. This is q of x here. And I'm subtracting this away. So here I've got nothing to subtract this away from. So I can think of this as being 0 x to the 4 y squared. And I've got none of these, but take away 5 of them. That would give me minus 5 x to the power of 4 y squared. There's nothing being subtracted away from this one, so that stays the same. But here I've got minus 7, subtract away 6 would give me minus 13. And then here I'm doing xy squared, subtract away minus 3xy squared. So if you're subtracting away a negative 3, it's the same as adding 3. So you end up with 4 of them all together. That's the sort of thing that you have to really slowly decide what is happening. You're not subtracting away 3, you're subtracting away negative 3. This term at the end, there's nothing to be subtracted away, so that stays the same. So this would be my final answer. And the negative numbers are the only thing that could possibly get mixed up a little bit. So just take your time. It's worth checking to see what's matching up, and then slowly writing down the individual solutions to form your polynomial solution. I've got some work for you. Good luck.